Oh boy. This doesn't look like anything really. This is looking pretty terrible. There's no square root, so I'm thinking that arctan might have the best chance. Normally I wouldn't be thinking arctan at all. I'd be trying to u sub it. It doesn't work. You can't turn it into natural logs or anything. The only thing I can do is to factor it, but it doesn't factor, not with a 25. I mean, 5 times 5, you're not going to get an 8 in the middle. But let's try to force factor it anyway. I mean, I'm desperate. So here's what I'm going to do. If only it was x squared plus 8x plus 16, that would factor. That'd be x plus 4, or x plus 4 squared. But man, I'm dreaming. It wasn't plus 16, it was plus 25. Well, why don't you just leave the 16 here and just put a plus 9 at the end? That's still 25. And the plus 9 can just come down. And you can rewrite the problem. And when I rewrite this part of it, I'm gonna lead off with the 9. With a little creativity, I can turn that into an arctan. First of all, I have to divide everything by 9. And I know that because this must be a 1. I don't have a choice. So if I divide everything by 9, this becomes the 1 that I need. All right, I have 12/9 up top, which I'm going to kick out. And as I kick it out, I'm going to reduce it to 4/3. It leaves me with the 1 that I want. I also have this other 1 that I want, which is perfect. And then I want it to be u squared du. But u squared is this thing. Whew, good thing your teacher at least gave you perfect squares to work with. That was kind of nice of me. So u is going to be x plus 4 over 3, or 1/3 quantity x plus 4 if you prefer. And so du, let's come over here, is just going to be 1/3 dx. So the 12/9 was already kicked out. I need a 1/3 on the dx. I need an extra 3 out front. An extra 3 out front will cancel with the 3 in the denominator, which is kind of nice. And so I'm going to get 4 inverse tangent of u plus c. Wow. That was kind of cool, but I had to be really creative to get that. You know what's really cool? That's great. The fact that I matched myself from earlier. Ha. All right. So again, you may have to do some sort of completing the square, if you will, or some rewriting, some clever, force factoring, if you will, to make this work sometimes. So, you have to use both sides of your brain, the creative side and the analytical side. And that's tough for a lot of people. A lot of people have a dominant side of their brain. They're artistic, but they're not mathematical, or vice versa. Some people have both. Some people have neither, unfortunately, but it's all good. All right, number 8. We're going to integrate this, and obviously we can't do any sort of u sub because of the 4th power. That -9 is really bothering me even more than the 4th power. We need to make that into a 1 right away. So let's do that. All right, now let's make our u sub. I think this probably has the best chance to look like arcsecant, so that's what we're going to go for. Obviously, the u squared has to be that x to the 4th over 9. That's a for sure. That means that u would be x squared over 3, or 1/3 x squared. And then du, to finish it off, is going to be 2/3 x dx. So we need a 2/3 x dx. I could multiply the top
by 2/3. Put a 3/2 out front. I think I'll do that. That way I have the 2/3. I've got the dx. I just need the x, and I'll have all three of these. I have an x, but it's in the wrong spot. It's in the denominator. And I can't move it up to the top. That's just not right. I need an x up top, but I can't give myself an x because it's not a constant. But I can give myself a 1 in the form of x over x, a little trickery. And now the three things that I've circled, 2/3 x dx, can become the du that I need. All right. Let's see what's left here. All right. These are all the dx. Those are gone. The 1 is still there. This is a 3. I don't know exactly what to do with it, so I'm going to kick it out. But actually, it's not a 3. It's a 1/3. In fact, you can see the 1/3 right here. So I could kick that 1/3 straight out. The 3's will cancel out. That's going to be a 1/2 in front. There's still a 1 up top. I can regenerate that. But this radical 9, or the 3, is gone. Oh my goodness. All right, we have the square root. And the square root is u squared minus 1, the way I need it to be. But I need a u out front, and I don't have a u. I'm close. I need a divided by 3 here. That way it's x squared over 3, and that can become the u that I need. By the way, x squared over 3 is always positive, so I know that the formula calls for absolute value. We're safe. Well, I multiplied the bottom by 1/3 to get that. I could also multiply the top by 1/3. And that way all the green stuff is a giant 1, and it's, no harm. And then this 1/3 could be kicked out. So eventually I'm going to end up with a 1/6 out there. And sure enough, it's going to be 1/6 arcsecant of u plus c. Of course, we don't ever want to leave u in the answer. What is u? Oh, it's circled even. It's x squared over 3. Let me replace that. And now we've got ourselves a really nice final answer for number 8. The trick there was multiplying by that x over x. That was sneaky but effective, and it allowed us to close the gap and finish the problem. All right, 2 more to go. Number 9 is next. All right, first it looks like it wants to be a u sub, but the 3 and the 2 are in the wrong spots for that to be able to happen. Oh, man. If it was just a 2 up top, it would be arctangent. It would be 2 arctangent of x plus c. I'd be done. But that ridiculous x to the 3rd is up there, and that's not helping things out. It's too top-heavy. And whenever a problem is too top-heavy, I hate to even say this to you, but you know it's coming. Long division with letters. It's our only hope. All right, here it goes. X squared times what is 2x to the 3rd? And hopefully you're thinking 2x. That would be correct. Okay, multiply. That'll be 2x to the 3rd. That better match. Plus 2x. Until we draw the line and change the signs, both of them. Remember, we have to subtract. All right, those cancel. Again, they better cancel. We picked the wrong thing up top. We have a remainder of negative 2x. And you know what we do with remainders? We put them over the divisor. So our final answer in the long division is going to be 2x minus a fraction that is 2x over x squared plus 1. All right, how does that help? Well, the reason it helps is because the original problem just couldn't be integrated, but this new look problem has a chance. So it's out with the old and in with the new. All right, that will be able to be integrated easily. Let me split it into 2 integrals. The 2x will get its own dx. I'll put the minus in the middle. And the second part, the fraction, will have its own dx as well. Okay. Well, the first part's easy. The integral of 2x is just x squared. That's super nice. The second part, at least it's bottom heavy now. Now we have a chance, and now we can u sub it. And we'll have the u simply be x squared plus 1. That means that du is 2x dx, and voila, we happen to have that exactly as we need, so that'll just become the du. This is simply 1 over u du. Still has the minus coming down. And the integral of 1 over u is natural log of u. So this problem is going to be finished in a blink of an eye. The final answer is x squared minus natural log of u, which is x squared plus 1. Normally I need absolute values, but x squared plus 1 is going to stay positive, so no worries. It's not wrong if you have them, it's just extra cautious. You do need the plus c always, unless it's a definite integral, but this one was indefinite. But our answer is definitely correct. And we're going to move on to number 10, which is definitely the last example. All right. Ooh, trigonometry. And we also have a definite integral. We're integrating from 0 to pi over 2, so probably get to review the unit circle on the fly. I was hoping it would be 1 minus sine squared, because that's a cosine squared. That would have been simple. But it's not. So we're going to have to u sub. And for the u, I would suggest just making it sine of x only. I was considering making it sine squared or 1 plus sine squared, but the derivative would be a lot tougher. In this case, if you just make u sine of x only, the derivative du is cos x dx, which is easily accessible. We happen to have it just where we need it. So that magenta circled thing is du. Come on down. And we have, let's see, 1 over 1 plus, and u is sine of x, so that's going to be u squared. And oh my gosh, I recognize that as the arctan. That's the arctan of u. Of course, I don't want to put a u in the answer. U is sine of x. And we're taking this whole deal from 0 to pi over 2. I can see the light at the end of the tunnel. We just have to be patient. So we start off with the arctan of, okay, sine of pi over 2, sine of 90 degrees, that's going to be 1, minus the arctan of sine of 0 is just 0. Okay, tangent of what is 1? Well, that's 45 degrees, or pi over 4. Tangent of what is 0? Well, just 0. I'm not even going to write that. Pi over 4 minus 0 is simply pi over 4. And we're simply finished with this section. All right.